Hi, this is a video on requirements modeling in software engineering. This is the agenda of the lecture that comprises of the requirements analysis, scenario-based modeling, UML model, behavioral model, identifying events with the use case, state representations, patterns, and then requirements modeling for web and mobile apps. If you look into the requirements analysis results in the specification of the software's operational characteristics, indicates software's interface with other system elements, and establishes constraints that software must meet. So whether you call yourself a software engineer, an analyst, or a modeler, so requirements analysis will allow you to elaborate on the basic requirements that are covered during the inception, elicitation, and negotiation phases that are a part of the requirements engineering. So the requirements modeling results in one or more of the following types of models, like the scenario-based models, which models requirements from the point of view of the various actors. Then we have the class-oriented models, which basically talk of the object-oriented classes, their corresponding attributes, methods or operations, and so on. Then we have the behavioral and pattern-based models that are basically modeled as a consequence of external events. Then we have the data models. They are depicted by using the information domain for the problem. Then we have the flow-oriented models, basically represented by functional elements of the system and how they transform data as they move through the system. So if you look at the overall objectives of requirements modeling, they are used to describe what the customer requires. They are used to establish a basis for the creation of software design, and they define a set of requirements that can be validated once the software is built. So there is an analysis rules of thumb that needs to be followed. So the model should focus on the requirements that are visible within the problem or the business domain. So it is expected that the level of abstraction should be relatively high. Then each element in the requirements model should add to an overall understanding of the software requirements, and that will provide further insight into the information, functional and behavioral domain of the system. Then delay consideration of infrastructure and other non-functional models until the design phase. Then minimize coupling through the system. So whenever I talk of coupling means interconnectedness. So whenever interconnectedness is higher, efforts should be made to reduce it, because when coupling is high, interdependencies are going to be high, and at a later stage, any kind of change to a module will propagate unintended side effects to the neighboring modules, and which is what we do not want to happen. So as far as possible, coupling should be as low as possible and hence should be minimized. Then be certain that the requirements model provides value to all stakeholders. You cannot focus on one particular group of stakeholders, so you should focus on all stakeholders. For example, business stakeholders should use the model to validate the requirements. Designers would probably use it for designing purposes. QA people would probably be using the model to plan some kind of acceptance tests and so on. Then you need to keep the model as simple as possible. Do not add any kind of additional diagrams if adding additional diagrams does not add any new information. As far as possible, use simple notations. Do not use any kind of complex notations so that the model becomes more complex. So when we talk of domain analysis basically is the identification, analysis, and specification of the common requirements from a specific application domain. The specific domain can range from avionics to banking, from multimedia to software embedded within medical devices. So the goal of this domain analysis is very clear and straightforward. So the goal is to find or create those classes or patterns that are broadly applicable so that the ultimate goal is reusability. So the next obvious question would be, is domain analysis an umbrella activity? Yes or no? Domain analysis is an umbrella activity. It can be viewed as an umbrella activity since domain analysis is an ongoing software engineering activity that is not connected to any other project. In a way, the role of the domain analyst is similar to the role of a master toolsmith in a heavy manufacturing environment. So the toolsmith will basically design and build tools that will be used by many people doing similar but not necessarily the same jobs. So the role of a domain analyst is to discover and define the analysis problems, the analysis classes, and related information. The application need not be the same here. So the key inputs and outputs for the domain analysis process. So the inputs come from different sources of domain knowledge, and the output is going to be a domain analysis model in various forms. So the input comes in the form of technical literature, existing applications, customer surveys, expert advice, and current or future requirements. That moves into a domain analysis, and the output is a domain analysis model in the form of Clark's taxonomies, reusable standards, functional models, and domain languages. So when you talk of the different elements of the analysis model, we have scenario-based models like use cases, class-based models like the class diagrams, behavioral models like the state or sequence diagrams, and the flow models like the DFDs, otherwise called the data flow diagrams. If you look at scenario-based modeling, the scenario-based modeling is basically talking of creating scenarios in the form of use cases, activity diagrams, and swim lane diagrams. So the success of a computer-based system or a product basically depends on the satisfaction level of the user. So if you can probably understand how end users will interact with your system, then the team will be able to properly characterize the requirements, build meaningful analysis, and design models, and that would be the ultimate success. So that is what a scenario-based modeling will do. So when you want to create a preliminary use case, The first two requirements engineering tasks like the inception and elicitation will provide enough of information that you want to probably write the preliminary use case. Then we have requirements gathering meetings, the QFDs called the quality function deployment, and other mechanisms that will probably be used to do all of these activities. So when you look at a simple example of a safe home project, the safe home surveillance function, which is considered as a subsystem, identifies the following functions that could be performed by an actor called the home owner. He will probably select a camera to view, request thumbnails, display camera views, or replay camera output, or access the camera surveillance via the internet, and so on, are some examples of functions that would be performed by the actor called the home owner. Then you need to go and refine the preliminary use cases. So it will have a description of the alternative interactions that is required for a complete understanding of the functions. So therefore, you probably need to get answers for the following questions. Question 1, can the actor take some other action at this point? Question 2, is it possible that the actor will encounter some error condition? If so, what it could be? And question 3, is it possible that the actor will encounter some other behavior at this point? If so, what would be the kind of behavior? So answers to these questions will result in the creation of a set of secondary scenarios that are part of the original use case, but they will all represent alternative behavior. This is a screenshot of how to write a formal use case, obviously taken from the Bible of Software Engineering. We call it the textbook by Roger S. Pressman, and this is the use case template that consists of the primary actor, the preconditions, the triggers, scenarios, priorities, and secondary actors, and so on. So this is also a preliminary use case diagram for a safe home security function where we have the home owner, the camera, and then the use cases are written in the box, represented as ovals. Then we move on into developing an activity diagram. Basically, the activity diagram will supplement the use case diagram, and this diagram will basically give you a graphical representation of the flow of interaction for a specific scenario. So these kind of activity diagrams will add additional detail that are not directly mentioned by the use case. So this is some kind of advantage of drawing an activity diagram, which would probably give you some kind of additional information that could not be depicted by a use case diagram. Creating a behavioral model could be done whenever there is some kind of an external event or a stimuli, and you want to probably model how your software will respond to this external stimuli. So in order to create a behavioral model, you need to follow the following steps, like evaluating the use cases to understand the sequence of interaction. Then you identify the events, create a sequence, build a state diagram, and then review the model. And review is important to ensure accuracy and consistency. So when you go for identifying the events with the use case, in general an event occurs whenever a system and an actor probably exchange some kind of information. So what is an event? An event is not information that has been exchanged. So I am not concerned about the information what is exchanged. but rather I am interested in the fact that information has been exchanged. So a use case is examined for points of information exchange. So to illustrate, reconsider the use case for a portion of the safe home security function we discussed earlier. So the homeowner uses a keypad to key in a 4-digit password. The password is compared with a valid password stored in the system. If the password is incorrect, the control panel will beep once and reset itself for additional input. If the password is correct, the control panel will await further action. So if this is a use case written, the underlined portions that you see here are basically scenarios that indicate events, like the homeowner uses the keypad, password is compared with a valid password, the control panel will beep, and so on, are nothing but scenarios that indicate events. So an actor should be identified for each of these events. Then the information that is exchanged should be noted, and any conditions or constraints should also be listed. Whenever you go for state representations in behavioral modeling, there are two different characterizations of states. The state of each class as the system performs its function, and the state of the system as observed from outside. So the state of the class will take on both passive and active characteristics. So a passive state is simply the current status, and an active state indicates current status as it undergoes a continuing transformation or processing, which means the state is active at present. Then you have the sequence diagrams. The sequence diagrams basically indicate how events cause transitions from one object to another. So once you are able to identify the events by looking at the use case, then you can probably go to draw a sequence diagram. A sequence diagram basically shows how events cause flow from one object to another, and a sequence diagram basically represents the flow from one object to another as a function of time. So in summary, we would say behavioral modeling during requirements analysis depicts the dynamic behavior of the software. The behavioral model uses input from scenario-based or class-based elements. In order to accomplish this, states are identified, events that cause a class to make a transition from one state to another are also defined. Then sequence diagrams are notations used for behavioral modeling. This video lecture has described what is requirements modeling and the different flavors of requirements modeling. So thank you. We will meet once again with more interesting lectures. Thank you.